Ozonolysis is another interesting reaction of an alkene, and then it takes an alkene and functionally splits it in half, turning them into carbonyls. In this case, we have, which would be what? 2-methyl 2-butanone, I'm sorry, 2-butene, and we turn that into acetone and acetaldehyde. So how do we do that? So this right here is what is known as a reductive workup. This is the mechanism we're going to learn first, and then there's also an oxidative workup, which I'll cover the mechanism for that in a different video. So like I said, first thing to do is remember, just conceptually, what I like to think of when I see this on my exam, conceptually, let's go like this. I put my oxygen and voila, I got the right answer. But sometimes you need to know for your exam, or you just should know anyway, the mechanism. Sorry, my lines here won't be perfect. But so what is that mechanism? So, well, first we have ozone, and ozone looks like this, where we have, these aren't the straightest lines either, sorry. Where we have one oxygen that has a negative charge. Actually, I'm going to draw this over top of it, because this is the best way to think of it. We have one oxygen, got to have a negative charge. We have one with a neutral and one with a positive. Now, we're going to do cycloaddition, where our negative one is going to attack the alkene. These are going to get electrons, pen's being weird, and then kicked up onto this oxygen, and then we're going to take these pi electrons and attack this oxygen. This is what's going to form what is called our primary ozonide, or our mol ozonide, so there's use a mole of ozone for each one. This system right here. Now, because it attacked an alkene, this is coming straight in the plane of the board, and in this case, we would have a CH3 going away. Why is this pen not writing? There we go. CH3 coming at us. I'm going to say we have a CH3 going away again, and then we have the proton coming at us. So then what happens is we get decomposition of this product here into just kind of ozone fragments. And this happens very rapidly and turns into what's called, is just a regular ozonide right here. And we'll go over the mechanism in a second, how we get to that. We have something that looks like this. Now remember, we only have, I'm going to draw the proton here explicitly. So what happens here? How do we get from this to this? So what happens, and there's not necessarily any order, is that this starts to break apart. Some of the electrons from here come, oh my God, this pen, come and attack that bond. Actually, sorry, no, that's the right way. Then these electrons come up here, attack that, and similar, then this bond comes and attacks this. So look at these ozone fragments, where we have positive charge here, and what else do we have? We have this. And then these rapidly recombine, where we're going to, this would be a negative, where this is going to attack this carbonyl. Then these electrons are going to be pushed up here, and these electrons attack this. And that gets us to our ozonide. Then our ozonide undergoes reductive workup with our dimethyl sulfide to give us these products here. Now, how do we do this? Generally, for most classes, they don't expect you to know the reductive nor the oxidative workup. But we can go through it right here. So I'm going to erase this if you need to take a screenshot, because this mechanism does get a little involved. So we have our ozonide, right here. And remember, we're explicitly drawing that proton. Ooh, that's not a proton, that's just a carbon. So what happens is we have our dimethyl sulfide. It's going to come, it's going to attack this oxygen, which is then going to attack this, which gives us an intermediate that looks kind of weird. It's going to look like this. I'm going to make sure I do this right. Positive charge there. Then it's being uncooperative. So this is what we have right now. We're going to have negative charge here as well. Then what happens is this is going to kick its electrons down to form our carbonyl, and we are going to then kick this off right here to form another O minus. So now we have formed our first carbonyl. We have acetone, but we still over here we have this product right here. Remember, this now has a negative charge. And similarly, we're going to come. Ooh, I lost a carbon in there. Got excited, lost a carbon. So we're going to come, we're going to attack that. We're going to kick this up onto here. And we are going to form our products. Then you also may have DMSO as your byproduct. Now, I know that's kind of a convoluted mechanism for a lot of people, and that's okay. It gets a little convoluted for me sometimes. But the most important thing to know is that when you have ozone and then a reductive workup, you make the carbonyl products. And we don't touch whatever is on the sides here. So let's walk through some examples real quick. So let's see, if we have just ethene right here, we do O3, first step, second step, reductive workup, DMS, DMS. What are we getting? We are getting formaldehyde times 2. And we already showed the first. Now, interestingly, if it's in a ring, think if we're in a ring, okay? So if we're in a cyclohexene, well, what happens there? Well, we do the same thing, except they're now connected still. So it'd be 1, 2, 3, 4, 5, 6. For our carbonyl, we have aldehydes on the end. And if there are methyls here, they'd be ketones. So it's important to remember that. And an easy trick for your exam, like I say what I do. So say it's this, or we'll use the easy example of this right here. And you want to know just redraw it on the other side. Here, I'll do on the other side. We'll do it on the other side. Just overextend that double bond, like really extend it. But draw it again, and just erase the middle. Put your oxygens on there. Boom. That's your answer. For more organic chemistry learning, be sure to hit that follow button.